Okay, YouTube, in our last video we discussed this idea that if we have a matrix A and it has an inverse that actually exists, we call this A inverse, that when we multiply these two matrices, what we end up with is our identity matrix, which is a pretty powerful and profound thing. It just means that we have something in our back pocket that can undo a given matrix. And so what we're interested in doing in this video is finding the multiplicative inverse of a given square matrix here. And so we're given some matrix A. Right off the bat here, we say this 2 by 2 matrix. What I want to do is find the inverse. So what we're going to do is we're going to outline a few steps here in order to do this. And so step number one is this. We're going to write a what we call doubly augmented matrix. Okay, matrix. And this doubly augmented matrix is of this form here, where we're going to put A on the left and we're going to put our identity matrix of a given order, same order as A, on the right side here. And so what this would look like for our given matrix up here, A, is what we're going to put is our A on the left and our I on the right. And because A is a 2 by 2, we get this 2, 1, 5, 3. I'll put our vertical bar down in the middle here. This is my vertical bar, and we'll put I on the right side. So the way this works, okay, is that when we have it written this way, right now the left side represents our A and the right side represents our identity. But what we're going to do is we're going to use Gauss-Jordan. Okay, so this is a little bit more. Let's see if I spelled Jordan correctly there. Let's see, Gauss-Jordan. No, I didn't. So Jordan. Let me get that out of the way there. So Gauss-Jordan elimination. So Gauss-Jordan elimination, essentially, what that does is it transforms the left side of this to become the identity matrix. So use Gauss-Jordan elimination to transform the left side of the augmented matrix into I. Remember that if we're going to do Gauss-Jordan elimination with a system, that was wanting to get ones down the main diagonal, but zeros underneath, not just underneath, but also on top. And as you recognize now, I hope you see that anything in this reduced row echelon form is, a matter of fact, the same thing as what we see as an identity sometimes. So what we're going to do is use this Gauss-Jordan elimination on the left side of this matrix to turn it into the identity, and then we'll proceed from there. So let's go ahead and talk about this. First of all, if I wanted to get a 1 in the top left corner here, one thing that we could do is we could take everything in that first row times a half. So what we end up with here essentially then is this. We would say that the second row doesn't change, 5, 3, 0, 1, and the first row would become 1, okay, 1 half, and 0. Now that we have a 1 here, though, what we want to do is use that 1 to get rid of the 5 below it. So what we're going to do is we'll take that positive 1 there times a negative 5. So we say negative 5 times our first row. We're going to add that to our second row. So in this particular case, we would say that the first row, it kind of stays the same, 1, 1 half, okay, 1 half, 0. But if we were to do negative 5 times 1 plus 5 here, we definitely have a 0 here. Now negative 5 times a half, which is negative 5 halves here. If we were to add negative 5 halves plus 3, or 3 over 1, which is what I'm doing right here, is negative 5 times a half plus 3, we would see that our common denominator here, it seems, would be 2's. So we would say negative 5 halves plus 6 halves would give us a single half here. So this would be a half. Okay. If we took negative 5 times a half and added it to 0, we'd just get negative 5 halves plus 0. So we get negative 5 halves here. And then last but not least, negative 5 times 0 plus 1, this would just stay a 1. So now that we've got a 1 here and 0 underneath it, what we're going to try next is to get a 1 right there. And so, of course, anytime we want to multiply by something to get a 1, we're going to multiply by the reciprocal. So we're going to take 2 over 1 times row 2. So row 1 stays the same. We have 1, 1 half, 0. But in row 2, we get 2 times 0 is 0. 2 times a half is 1. 2 times negative 5 halves, well, what's going to happen here? Well, our 2's kick out, we get just negative 5. So we're going to get a negative 5 here, and then 2 times 1, of course, is 2. So now, because we're going for Gauss-Jordan elimination, this means that now that we've got a 1 here, we have to get zeros below and above it. And so to get a 0 above it, what we'll do is we'll take it times a negative a half and add it back to row 1. So we're going to do negative a half times this 1, which is in row 2. We're going to add that back onto row 1, which will get the thing above it to be 0. So because we're using row 2, I suppose row 2 does not change here. We get this guy right here. And on the left side here, let's see. If we took negative a half times 0, it'd be 0. 0 plus 1 is 1. And if we did negative a half times a 1, that'd be a negative a half plus a positive a half is a 0. So now we've gotten our identity on the left. Let's talk about these last two entries. If we did a negative a half times negative 5, so let's see, negative 5 times negative a half, be negative 5 over 1 times negative a half, that'd be a positive times a positive. We get 5 halves here. So in this case, we would get 5 halves, and we have to add that back to the original a half. And so 5 halves plus 1 half is 6 halves, and we get 3. So this would be a 3 here. And if we did now, this would be a little bit easier here, negative a half times 2 would be a negative 1, and negative 1 times 0 is negative 1. So what I want everybody to see here is this. Step 2, I had mentioned we're going to use Gauss-Jordan elimination to transform the left side of the augmented matrix into I. And so what you can see here is that we've gone from this very top augmented matrix, which was AI, and what we get now is something that looks like this. I, and what I'm going to say is B. So we get this down here. We say I is on the left, and this is doubly augmented with B, but what we can say is, step 3 here, the value of B is A inverse. That is to say that the matrix that results on the right side, of IB is really I on the left, A inverse on the right. So that is to say, to find the A inverse here, what we're going to see is that it's just this part of the matrix, and we say that A inverse then has to be this 3, negative 1, negative 5, and 2. So step 4 when finding an inverse is check to see they undo each other. And so what we're going to write here is essentially this. We're going to see that if we take A times A inverse, that we actually do indeed get I. So with our two matrices here, we started with this up here, we say 2, 1, 5, 3. I'm going to go ahead and take that. We say this is like our A, 2, 1, 5, 3, A. And what we did was we think we found A inverse, which was the right side of this doubly augmented matrix here. So we're going to put this in, we say 3, negative 1, negative 5, and 2. And because we're taking a 2 by 2 times a 2 by 2 and our inner dimensions match, this is defined. And because we get the outer dimensions for our product, I'm going to make a blank 2 by 2 matrix over here. We'll go ahead and fill this out. Looks like we get first row, first column be 2 times 3 plus 1 times negative 5. So 2 times 3 is 6, plus 1 times negative 5 is a negative 5. Going first row, second column, we get 2 times negative 1, negative 2, plus, now move over, move down, 1 times 2 is 2. Here we'll go second row, first column, so 5 times 3 is 15, plus now 3 times negative 5 is negative 15, and last but not least, we'd say 5 times negative 1 here, negative 5. Move over is 3, move down is 2, so we say plus 3 times 2 is 6. What we end up with here is this 1, 0, 0, 1. And so I'm not going to multiply these in the other order. I'm just going to suggest that then we have found the A inverse, and generally speaking, the way that we do this is you just make your doubly augmented matrix and then RREF the left-hand side, which will leave the inverse matrix on the right-hand side here. Cheers.